we started to talk about trusses. And trusses, in a very simple word, members connected together by something called joint, and the whole structure is supported by supports. This structure can be called truss. The main target in this topic for trusses to figure out what is the internal force in each member. How much force in this member, how much force in this member, how much force in this member. I told you last time, sometimes we have members with zero force. There is no internal forces in these members, which called zero force members. Just to remind you, we have two cases. Do you remember? Case number 1. We have 3 conditions. We have joint with 3 members. Your joint must have 3 members. 3 members only. 2 of these 3 members, 2 of them are collinear. The third condition, no external force or forces at this joint. So just to give you example, this joint has 3 members. This joint has 3 members. This joint has 3 members. Which one of them is matching with this case? We have joint with 3 members. This joint has 3 members. This joint has 3 members. This joint has 3 members. This member, 1, 2, 3. This one is a force, 10 kilonewton, so it's different. Okay, second condition. 2 of these 3 members are collinear. Do you think we have 2 members here collinear? Collinear means on the same line, like this, or like this, or like this, on the same line. Do you think we have 2 members on the same line? No, forget this case, or forget this joint. Do you think we have here 2 members are collinear? I believe yes. This one and this one. So this one still works. Do you think we have here 2 members are collinear? I believe yes. This one and this one. That means this member is still working. Third condition. No external forces at this joint. Do you have any forces, any given forces at this joint? No, this joint is still working. Do you think we have external forces at this joint? Yes, we have 10 kilonewton. This joint will not working anymore. So, final decision, the third member is 0 force member. This member is 0. This member has 0 internal force without calculation. Any question, guys, so far? Any question so far? Okay, we have another case. Case number 2. Case number 2, we have joint with two members only. I said two members only, and no external forces at this joint. Only two conditions. Very simple. But we are talking about joint with two members only. For example, this joint, this joint, this joint. What do you think? Let's see. I'm talking about joint with two members only. Do you think this joint has two members only? Yes, I think. This one and this one. So this joint still working. Do you think this joint has two members only? No. We have 1, 2, 3. So this one is rejected. Do you think this joint has two members only? Yes, I think. This one and this one. So this joint is still working. What about the second condition? No external forces at this joint. Do you have any external forces at this joint? No. This joint is still working. Do you think this joint has external forces? Yes, I think. 10 kilonewton, it's given. So this joint no longer working. Final decision, the two members are zero force members. The two members at this joint are zero force member, both of them. Do you think you have any question regarding this point? Guys, if you have zero force member, if you have one member with zero force, go ahead and delete it from the truss. It's nothing. Cannot affect the structure because it's zero. It's nothing. So the question is, why we are putting this member in the truss? We have many reasons, but it's outside the scope of this course. One of the reasons, effect of temperature during summer or during winter, effect of settlement. Probably we have settlement in the soil foundation. Probably for any other reasons. We have many reasons. And these reasons, these members are important. But in this course, if your member is zero, they are nothing. You can delete it. Okay. We have example. This example only asking for which members are zero force member. This question will be the same. You will have the same one in the exam. Identify all, please remember all. So don't forget any. Zero force members in the shown truss. Let's start. Start with what? Okay, let's start with case number 1 or case number 2. What do you think? I will search for which case. Let's start with case number 2. It's very easy. Case number 2. Let's start with case number 2. But I highly recommend in your exam, in your quiz, in your homework to solve this type of problem, to redraw this truss one more time with your pencil. With your pencil. We have hinge. We have roller. We have force here. F2. How much? I don't care. How much? About F1? I don't care. Let's start. Just to remind you, case number 2, we are looking for joint with 2 members only. No external forces at this joint. Guys, which joint has 2 members only? Which joint has 2 members only? I highly recommend to start with case number 2. After you are done, I will go to case number 1 to check. So what do you think? Which joint has 2 members only? B and D. B and D. Thank you, Mitchell. Guys, until this moment, I didn't add the extra points. I have few students has extra point. I will do it today. So after today, you can check the extra point. 3 points extra in the previous exam. If you have 100, I'm so sorry. Your 3 points are done. So sorry. So it's your mistake. You got 100. So not my mistake. Anyway, so point B and point D. Perfect. But be careful. Joint B has 2 members only. Do you have any external forces? Do you have any external forces at this joint? One of you will say, yes, we have. Where? We have F2 and F1. No. I'm talking about joint B. Do you have any external forces acting at point or joint B? No. That means this member and this member will be 0 force members. 0 force member. So this one is 0 and this one is 0. Just circle the member. Don't circle the joint. Circle the member so I can understand member AB is 0, member BC is 0. One more thing. If your members are 0, please go ahead and delete them. This is the reason why I told you, please redraw the truss one more time with your pencil. If your members are 0, go ahead and delete them. What else? Joint D. For joint D, we have 2 members. Yes, we have 2 members at this joint. Do you have any external forces? No, no external forces at this joint. That means this member and this member will be 0. Believe me, will be 0. So this member and this member are 0 force members. If your members are 0, go ahead and delete both of them. Do you think we still have joint with 2 members only? I believe yes. This joint has 2 members, this one and this one. And this joint has 2 members, this one and this one. So joint A and joint E. One of you will say, hey, wait. Joint A has 3. 1, 2, 3. Yes, I know at the beginning. But right now, after I deleted this member and this member and this member and this member because they are 0, joint A became 2 members only. So first condition is good. Joint with 2 members only. Please go ahead and check the second condition. No external forces at this joint. Do you think we have external force at this joint? Yes or no? Do you think we have external forces at this joint? Yes or no? Guys, are you here? At A, yes. I'm talking about A. Right now, joint A has 2 members only. After I deleted the vertical one, because the vertical one is 0. So the question is, do you think joint A, which has 2 members, joint A has external forces? No external forces. No, that's wrong. Guys, we have at A reaction, YA and XA. We have at E reaction because it's roller, YE. Reactions are considered external forces. Reactions can be considered external forces. So I cannot say this member and this member are 0. I cannot say this member and this member are 0. I am done. I am done. One more time. I will start to check any problem with case number 2. I'm talking about joint with 2 members only and no external forces. Remember, if you have reactions, reactions can be considered external forces. One more time, which is very important, and be careful. Don't forget it, please. If your members became 0, go ahead and delete them from the truss. Go ahead and delete these members from the truss. Okay, let's start to check the second condition. I'm sorry, the second case. Do you remember the second case? Joint with 3 members. 2 of them are collinear. No external forces. Let's start. Let's start. Start with what? Okay. This joint, do you have 3 members? No. This joint, do you have 3 members? Yes. Yes. This joint, do you have 3 members? No. I have 4. This joint, do you have 3 members? No. This joint, do you have 3 members? Yes. This joint, how many members? 4. No. This joint, how many members? 3. Yes. This joint has 3 members? No. So I have 3 expected. Joint. Second condition. 2 of them are collinear. This one and this one are collinear. Yes. This one is still working. Do you have 2 of them are collinear? No. The 3 members, everyone in different way. So this joint, no. For this one, do you have 2 are collinear? Yes. So this one is still working. So we have 2 joint. We need to recheck. External forces. Do you think this joint has external forces? No. That means this member will be 0. This joint, do you think we have external forces? Yes, F2. So this one is failed. I cannot say anything about this joint. So the final decision for this check, this member became 0, which is member HI. If your member is 0, I can delete it. Once you delete this member HI, please go ahead and check this joint one more time. Sorry. Go ahead and check this joint one more time. How many members at this moment? 3. 1, 2, 3. 2 of them are collinear. No external forces here. The third one will be 0. So this member will be 0. So I can delete it. This member is 0, so I can delete it. Make sure we are done. No joint with 3 members. 2 of them are collinear and no external forces. If you check the remaining truss, no way. We are done. One more time, guys. This joint, how many members? 3. 2 of them are collinear. What is the problem? The problem is we have external force F2, so I cannot consider it 0 force member. So the final decision for this example, we have 6 members are 0. This one, because of joint B. This one and this one because of joint D. This one because of joint H. After you delete this member, joint I is good to make this member 0 force member. So guys, what do you think? Do you have any question? This point is very important. This point is very important. This point or this part in this topic is very important. One more time, one more example. One more example. We have a truss with external forces 2 kip and 2 kip. We have, I suggest to put your reaction and try to avoid forgetting them. So we have hinge. So we have 2 reactions, one called XA, one called YA. We have roller, so we have one reaction FY. And remember, reactions are considered external forces. Okay? Okay. My recommendation to start to solve this problem to redraw the truss. We have here hinge, so we have 2 reaction. We have here roller, so we have 1 reaction, and we have external forces 2 kip. We have external forces 2 kip. Let's start. I suggest to start with condition with case number 2. Check if you have joint with 2 members only and no external forces. We have this joint, 2 members only, this one and this one. This joint has 2 members only, this one and this one. That's it. Joint A and joint F. If you try to check any other joint, no way. These joints are 2 members only. Do you think we have external forces? Yes, I think. At this joint, joint A, we have reaction. At joint F, we have reaction. So no way. No way. I cannot say we have 0 force member at these locations. Because the second condition in this case, no external forces. So I am done with case number 2. I am done with case number 2. Let's start with case number 3. Guys, I have question. Case number 3 said joint with 3 members. 2 of them are collinear. No external forces. That's right? What about this joint? How many members here? I'm talking about joint number n. This joint. How many members at this joint? How many? 4. So it looks like Mitchell, you are the only person in this class. Do you think we have many other students? Guys, are you here? Guys. Okay, okay. To make sure. So, joint N. I'm trying to teach you something. Joint N, how many members? 1, 2, 3, 4. Forget it. Forget it not for all, but forget it at this time. Because we need the joint with 3 members only. So at this time, joint N has 4 members. Okay, what about joint K? Joint K. What do you think about joint K? How many members? I think we have 3. 1, 2, 3. That's right? Yeah. So 3 members only. Perfect. Joint K. 2 of them are collinear. Yes, I think this one and this one are collinear. Yeah. No external forces. Yes, we don't have external forces at this joint. That means the third member is 0. Do you agree? So this member is 0 because of joint K. Because of joint K. Once your member is 0, go ahead and delete it. I deleted this member because it's 0. Then go back to joint N one more time. At this moment, how many members at joint N? 3. 1, 2, 3. Do you have external forces? No. That means this member will be 0. So this member Ln is 0. Go ahead and delete it. What about this joint? How many members? 1, 2, 3, 4. Forget it. What about this joint? How many members? 1, 2, 3, 4. Forget it. What about this joint? Wait. This joint M. I'm talking about this joint M. I think joint M has 3 members. 2 of them are collinear. No external forces at this location. The third member will be 0. So this member, which called MB, is 0. If your member is 0, go ahead and delete it. Sorry. Go ahead and delete it. Once this member is deleted, go back to this joint. Right now, this joint has 3 members. 2 of them are collinear, no external forces. The third member will be 0. So this vertical member is 0. Once this member is 0, go ahead and delete it. Once this member is deleted, go back to this joint one more time. How many members right now? 3. 2 of them are collinear, no external forces. This member will be 0. So this member will be 0. Okay, keep going. Go ahead and delete it. My question is, at this joint, how many members do you have? 3. 2 of them are collinear. Do you have any external forces? Yes, we have to keep to down, not to up. We have two kept, so I cannot say we have 0 force member. So final decision, all of these members, KN, NL, LC, LB, MB, all of these members are 0 force member. The same will be done on the other side. This member is 0 at this joint. So this member is 0. Delete it. At this joint, we have 3 members. 2 of them are collinear. No external forces. This member will be 0. So this member will be 0. I can delete it. So I'm done. I cannot say anything from here. So I will go for this member. At this joint, this member will be 0. Delete it. This member will be 0. I can delete it. This member will be 0. I can delete it. So the final shape of this truss looks like this. If you are trying to watch any joint with 3 members, like this one, okay, we have 3 members. 2 of them are collinear, that's fine. But we have external forces, so I cannot do any more. So the final decision, all marked members are 0. The remaining members will not be 0 force member. Any question? Any question so far? Your quiz on Monday will be something like this. I will give you a truss and I will ask you to identify all 0 force members. During exam number 2, you can expect one problem like this. I will give you truss and ask to identify all 0 force members. So I highly recommend to redraw your truss with your pencil to make sure you can delete the 0 force member, because if you delete one, probably will give you another chance to figure out a new one behind or beside it. Okay, we need to figure out the internal forces in other members. Okay, we are done, but we still have this member, and 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 this member. We need to figure out the internal forces in these members. Then these members has a value. So we need to figure out these values. The first method I will cover today is joint method. This method is not new. We covered it one time during module number 2. If you have joint like this, if you have joint, or you have particle, or you have point, and we have many forces like this one, and this one, and this one, and this particle or this joint or this point in equilibrium. That means summation forces in x equals 0, summation forces in y equals 0. That's it. If you have joint with many forces, I don't care how many forces do you have. My concern is this joint in equilibrium, yes. So summation of all x component equals 0, summation of all y components equals 0. Guys, we are talking about truss in 2D, 2 dimension. We will not talk about anything in 3D more in this course. We are done. So everything in 2D. So you need to figure out what is the x and y component for this one, what is the x and y component for this one, what is the x and y component, xy component, xy component. Finally, summation of all x components equals 0, summation of all y components equals 0. Once you are done, I can figure out these forces how much. Let's try this example. But before trying this example, anybody has any questions so far? Do you have any questions so far? Okay. Guys, for this truss, please make sure you are reading what is required. Do you think this truss asking to identify zero force member? No. The problem didn't say this. So please don't waste your time to figure out which member are zeros. Don't waste your time to figure out case 1 or case 2. Don't waste your time to figure out which joint has 2 members or 3 members. Because the problem didn't ask to identify zero force member. So can you read here? Determine the force in members. We have specific members. We need to look to them only. AB, AE, ED. AB, AE, and ED. These members only. Can you go back to this problem? Can you make sure you read it carefully? This problem asking to identify all zero force member. So we need to check all members and figure out which one is zero. And if this member is not zero, I don't care about it. So make sure you are reading the problem carefully. Okay. We are looking for member AE, AB, and ED. Unfortunately, the first step in this type of problem, you have to calculate your reaction first. We have hinge here, so we have one reaction called YA. We have one reaction here called XA. We have one reaction here called YC. Go back to the previous module to figure out your reactions. We have 3 equilibrium equation. Summation f of x equals 0 for the whole problem. So we have negative xa. We have positive 6. This one equals 0. The only unknown is xa will be positive 6. Summation f of y equals 0. What do you have in y direction? We have positive ya. We have negative 8. We have positive yc equals 0. Nothing else. Third equilibrium equation, summation moment at any point equals 0. Guys, do you remember my recommendation? If you are talking a moment about any point, I suggest to take moment at support. We have 2 supports, A or C. Both of them works, but I highly recommend to take moment at A with larger number of unknowns, larger number of reactions. And I'm going to assume this direction, which is clockwise, positive. If you take moment at A, we have XA times 0. We have YA times 0. We have 8 times 2. Remember, your force and your distance must be perpendicular. We have negative YC times 4. We have positive 6. Don't forget it. Times 2. This 2. Nothing else. This one will be cancelled. This one will be cancelled. The only unknown in this equation will be y. Just a second. How much YC? 8 times 2 plus 12 divide 4 will be 7 kilonewton. Go back here and put YC equals 7. Your YA will be positive 1. Guys, to make sure everybody in this class can do it correctly. Here, YA, which is positive, minus 8 plus 7 equals 0. That means YA will be negative 1 equals 0. If you move 1 to the other side, so YA will be positive 1. Make sure you are doing it correctly. So YA equal 1. XA equals 6, YC equal 7. Any question so far? Any question for reactions? Reactions are very important. Okay. We are looking for member AE and the member AB as a first step. ED in a different location. What you mean by different location? I mean member AE and AB intersects, both of them intersecting at A. So I'm gonna draw a circle around A. Can you tell me what do you have at A? Here is joint A. What do you have at point A or joint A? What do you have? What do you have inside this circle? This circle. What do you have? We have horizontal reaction 6. We have vertical reaction at A, 1. What else? We have this member which called AE. We have a force here, FAE. What else? Please don't forget any. We have horizontal member intersect at A called AB. So you have a force here called FAB. Do you think we have anything else intersect at A? Guys, this point is very important. Do you think we have anything else intersect at joint A? We have horizontal reaction, vertical reaction, this member and this member. Do you think we have anything else? I believe no. No. Okay, by the way, if this length is 2 meters and this length is 2 meters, what do you think about how much this angle? 45 degree. 45 degree. Do you agree? Because this angle is 90 and this length equal to this length, so this angle will equal to this angle, so one of them will be 45 degree. So this angle is 45 degree. Guys, I went back to module number 2. Summation f of x equals 0. What do you have in x-axis? We have positive FAB, this one. We have negative 6. We have positive FAE cosine 45 degree. Do you agree? This force will have 2 components, one horizontal and one vertical. The horizontal component will be FAE cosine 45. The vertical component will be FAE sine 45. So anything in X will be this one, and this one. Make sure you are using the correct sign. Equal 0. How many unknowns? 2. This one and this one. Forget it. Summation f of y equals 0. What do you have in y direction? We have positive 1. Positive? Yes, this one is going up. Going up. And we have positive FAE sine 45 degree. What else? What else in y direction? Nothing else. Equal 0. The only unknown in this equation is FAE. How much? It will be negative, first of all. it will be 1.4 kilonewton. Please go back to this equation. FAB minus 6 plus how much for FAE? Negative 1.4 time cosine 45 degree equals 0. The only unknown in this equation is FAB, so I can figure it out. It will be 7 kilonewton. So I have question. FEE, how much? 1.4. Member EE, how much? 1.4 kilonewton. Member AB, how much? 7 kilonewton. Any question so far? Second question. Do you think AB or AE tension or compression? What do you think? I assumed AB in this direction, which is tension. I assumed in this direction, which is tension. Do you think your assumption is correct? Yes. Because FAB equal positive. So my assumption is correct. That means this member will be tension. FAE, you assumed a tension like this, and you got negative value. That means my assumption is not correct. I assumed a tension. It's not correct. This member is compression. So beside your value, I'm gonna say AE is compression and AB, which is 7, will be tension. We are still looking for ED. I'm gonna continue next time. Until this moment, guys, do you have any question? Please, trust in your exam will be 2 questions. 2 questions on this topic. First one, how to figure out zero force members. Second question, something like this. I will give you a truss, so you need to figure out the reactions correctly. Then you will select one joint with the intersection of the required member. So because one of you will ask me, why you choose point A? It's a good question. The answer is very simple. Because I'm looking for this member, and both of them intersect at point A. So I selected point A to put everything at this point and apply equilibrium equation, summation of x, summation of y, to figure out the forces in this member. I assumed my direction for this force and this force in tension side, and I wait for the sign. If your sign is negative, your assumption is not correct. It will be compression, not tension. If your sign is positive, your assumption is correct, so it will be tension.